Hey YouTube, what's up, Zeslink? Welcome back to another episode of Coding Session. It's been quite some time since episode 20, but I made a big move across the state. I graduated with my bachelor's degree in computer science, and I am a software developer in the industry. So it's been quite a wild ride since the last episode, and I haven't been as active as much due to life, family, and my new role as a software developer at the company I work at. And if you haven't checked Slinksoft recently, I've also ended the Slink OS development simply because I do not have time for it, and also with the current state of Windows 10. You can read more about that on Slinksoft. I encourage you to check it out. I just don't think it's worth continuing development with it. Too long didn't read version, a lot of features. I started SlinkOS during the development of Windows 8, transition of Windows 8 to Windows 10, where some features, obvious features like clipboard history, snippet tools around, but it wasn't as defined as it is today, etc., just were lacking in Windows 8 and beginning of Windows 10, and I simply programmed those. But now, since Windows 10 is pretty much has all those features and possibly more, there's no point, even though I do take pride in my work with SlinkOS and the various tools I've implemented. So thank you guys for the support over the years for that. Even with life, family, and working on projects at my company, I still want to do something on a more personal level. And I probably explained, I don't know if I explained it in Slinksoft, I still want to do Android mobile development. Haven't had an idea for an app in a while, though. I probably want to get back to game development like I did back in the days, especially on this channel. I did lots of game development. Or do what we're doing now is coding session. Since I usually like to record and upload raw because I'm too lazy to edit. And that's actually a bit harder because if I mess something up, then I have to start over and whatnot. But there are some episodes on the channel for Coding Session that have been edited and recorded in multiple parts. But usually I like to upload raw and just upload it to YouTube. So let us get started. So this is episode 21. We are on the validate binary search tree. So given the root of a binary tree, determine if it is a valid binary search tree. A valid binary search tree is defined as follows. The left subtree of the node contains only nodes with keys less than the node's key, obviously, and the right subtree of the node contains only nodes with keys greater than the right node's keys, obviously. And left and right subtrees must also be binary search trees. Now, we've done plenty of episodes going over binary search trees and traversals. We can use a traversal for this example. And this is actually the solution I'm about to show you. Implements something that I don't usually use, so I had to refresh myself. That's why I have Stack Overflow open, and I will explain that when we start writing code. But if you're not familiar with the traversals, we went over it in previous episodes. You have in order, pre-order, post-order, and level order, which is the slowest. That is a breadth first search, while depth first search is in order, pre-order, and post-order. So for this solution, we can implement one of these traversals. In this case, it would be probably a good idea to implement in order traversal, which is going all the way down to the left subtrees, exploring those, going up to the root, and then exploring the right subtrees recursively until we've searched the entire tree. So if there's an example, it would be 4, 2, 5. Left is 4, root is 2, right is 5, and go up to 1, and then which is the left in the root in a sense, and then the 3, which is obviously the right. And we can do something similar for trying to validate these trees. Now, since we're doing in order, we don't have to check less than and greater than, but if we check one of these ones, depending on the solution, because there's many ways to do this, we will be A-OK. So we're going to implement int question mark previous node question mark. As I said with that Stack Overflow, I had to refresh myself. Is a nullable type. So this int can be nullable. Usually ints cannot be nullable. This is for if we reach an end of subtree, or the actual tree itself, it doesn't just default to 0 and then the solution gets ruined on our submission. It's nullifiable, and we can continue going on exploring the tree. Okay, so we need our base case here because this is going to be a recursive. So if root is equal to null, return true. And then we're going to do if not is valid BST traversing root.left. And usually just going through checking conditions for root.left, or if that returns false, which this is what's about to return false, or root.value is less than or equal to the previous node. Now, okay. Sorry, thought I heard something in my house. Root.val is less than or equal to previous node. We want to simply return false. If not, we're going to store previous node. To the current value. So as you see, we got is valid BST root.left. Previous node is equal to root value. And then return is valid binary search tree root.right. Now, you got left, root val, and then root right. So this is more of an in order style implementation. So if we start from 1, if 1 is, now if, this is where it kind of gets confusing with the first, but let's ignore this first case because it's either or. If root.val is is less than or equal to the previous node, there's no previous node here. So it's not going to return false. It's just going to continue traversing with the in-order traversal. Previous node is equal to root.val and then do root.right. Let's go up to 2. If 2 is less than or equal to the previous node, which is 1, that is false. So it will not return false and continue the traversal. And it's going to go to 3. If 3 is less than or equal to 2, nope. So it's not going to return false. This whole tree is going to be true, just like it is in example 1. Example 2, however, is an example of it being false. So this passes. Okay, that's cool. 5 is less than or equal to the previous node. That's false. But if we go ahead and continue exploring down these trees, which probably be 3, which obviously 3 should be chained down here to 1 on the left subtree. If 3 is less than or equal to that previous node of 5, false right away, it is not a valid binary search tree. And that's kind of how this implementation works. Of course, we need this nullifiable previous node so it doesn't automatically default to 0, because then the solution will be wrong on one of the use cases. So we want to make sure it's nullifiable because anything beyond 1 or 3 or 6 is going to be null. There's not going to be a left or right. It's going to eventually be null when it gets to that chain, or at least attempts to. Let's run our code. Compile error. BST. I think this is a case error. Yep, case error. Whoopsies. Lowercase I instead of capital I. I did the same thing here. Wow. Because I guess I'm not too sure. I believe this defaulted to capital is valid. I would have just changed that to lowercase I. So maybe that was just a mistake on LeetCode's part. I think this is LeetCode's problem. But there we go. Solution is accepted. Now let's do all the use cases. There you go. Runtime 132 ms, faster than 14.58% of all the other C# solutions, which is good. And we did better on the memory usage. So using in-order traversal and nullifiable types and comparing it to the previous node, and checking if that current value is less than or equals to that previous node. And of course, doing it in a style of an in-order traversal, which is depth first search style algorithm. We were able to validate some binary search trees today. So I just want to say thank you guys for watching. And for all the support over the years. If you head over to Slinksoft, there's more information on a company I work for, some of the Publix projects I was working on, and Slink OS, and possibly the future of Slinksoft. But I definitely would like to do more coding sessions like this, since usually, again, I upload raw and then ship it off to YouTube, because most of the times I don't have to do multiple takes or record in multiple parts and then edit things out or in. Yeah, thank you guys for watching, and I hope you guys have a nice day. Peace.